Hi classmates, we are here to teach you about organic chemistry. We will learn about two substitution reactions, SN1 and SN2.
SN2 mechanism. From its rate law, it can be observed that it depends on the concentration of a strong nucleophile and either a methyl, primary, or secondary substrate. This is a concerted reaction whereby bonds are formed and broken simultaneously and forms a five-member transition state. This reaction usually takes place in a aprotic solvent. The SN1 mechanism. Its rate law states R is equal to K concentration of substrate. It can be observed that it depends on a tertiary or secondary substrate. This is a non-concerted reaction, so it occurs in two steps. First step, formation of a carbocation, where the leaving group leaves the electrophilic carbon by removing one pair of electrons. The second step, the nucleophile then bonds with the electrophilic carbon by donating one pair of electrons to it. This reaction usually takes place in protic solvents. Also, ideal leaving groups for both SN1 and SN2 are fluorine, chlorine, bromine, and iodine.
In an SN2 reaction, the nucleophile uses an unshared pair of electrons to bond to the electron-deficient electrophile. As the reaction starts, the bond to the chlorine begins to break and the hydroxide ion begins to form. At this point, there are two partial bonds forming a five-membered transition state. As the energy of the system decreases, the bond to the chlorine breaks. The nucleophile attacks from the backside, therefore the reaction has occurred with inversion of configuration. The products formed are methanol and chlorine.
In this SN1 reaction, the bond between the Cl leaving group and the electrophilic carbon begins to break, and a pair of electrons is given to the Cl leaving group. After the Cl leaves, a carbocation is formed in its first step. Now the ethoxide ion has three pairs of valent electrons and will now bond with the carbocation by donating one pair of electrons to the electrophilic carbon.
In conclusion, SN2 reactions occur with a strong nucleophile and a methyl or primary or secondary substrate in one step in a polar aprotic solvent, while SN1 reactions occur with either a secondary or tertiary substrate in two steps in a polar protic solvent.
Created using Powtoon.